Hey guys, this morning we are picking back up, working on getting some of the CSV operations in place for the example application we're writing here for managing the inventory and the retail orders and stuff in like a storefront, like a collection of multiple stores here. So yesterday we had gotten a function written that takes in a customer ID and then returns the customer record here, or not returns, just prints it to the console, right? Um, and we'd started out by doing that for all the customers, and then we decided, you know what, we really probably don't want to just display all the information, including the password for all the customers. So let's get it just for a single customer, right? And I mentioned yesterday the concept of CRUD operations. That is create, read, update, delete, that acronym there. And these are things that you very commonly want to do with data. And so it's pretty typical in applications where you're working with data systems to enable these operations on different sorts of things you're working with. Once we get into object-oriented programming, very typically you do this with a specific object you define. So like you might have an employee record or something like that, where the employee probably has like an employee ID and a name and a start date and a salary and things like that. And you might want to update any of these fields on employee by updating the employee object. And you might want to create new employees if the company hires someone. So this is just very normal of, I guess, especially business applications the world over. But it's real stuff. This is how programs in the real world actually do work. I mean, albeit much more complicated, but same idea basically. So that's where we are right now. Now, yes, towards the end of yesterday, this is where the limitations of CSV files come out a little bit. You see, this is not super easy to just go in and update something, right? All we want to do is update one of the rows in the file, but we're writing this stuff. Now, it's good practice for you, but in the real world, with a database, you can literally take in stuff for a new object, change whatever object you're going to make. We'll get this when you do object-oriented programming. This whole function here that's like 20 lines is like 2 lines once you're using a database system, because it does a lot of the heavy lifting for you. You just say, hey, I want to update the thing with this ID, and then you give it a new object, and then it just updates it. At some point, we'll run a comparison once we get into database stuff more, and perhaps object-oriented programming. And we can come back and we can look at all the pain and suffering we're going through now, and then we'll appreciate like all of the stuff that the database programs and the thing that interfaces with the databases. It's sometimes called a cursor, like a SQL cursor, like CURSOR. I don't really know why, honestly. Like a cursor, you think like mouse cursor, right? I don't know why they call it that. I'm sure there's a good reason. I just haven't bothered to look it up. But the thing that lets you interact with SQL, at least in a lot of modern sort of packages for databases, just makes it super easy to add stuff, to delete stuff, to update stuff, so that you don't have to do code like this. And so we won't get too far off in the weeds of databases. I just wanted to get us kind of in the mindset that we're doing this now for practice with a very simple data system that's just storing things in comma separated value files like this. However, in the real world, you will use databases, and we'll get to them eventually as well, because they're an important part of learning how to do applications development, particularly for anything that starts getting bigger. You're fine using just normal data file, CSV, or what have you, when your application's small. But once your applications get big, for scaling reasons, for performance, you have to use databases, basically. Sneak peek. I did fix the problem with what I had yesterday. So towards the end of yesterday, I was sitting there scratching my head. It was like we were looking at this example that we found on Stack Overflow of how to kind of update rows, right? Like I said about like this CSV data store not being the most intelligent, we actually have to go through all of the data here and write it all back every time we go through the file. So that's not the most efficient, right? We'd like to ideally just find one record and then change that and not have to go through the whole file, but no, there you go. And so I'll have you come up with a way in which we can make this a little bit more efficient in a second here. But for now, I want to go through what this code is doing, because I think you'd expressed yesterday that you'd seen it and it wasn't quite clear to you. Is that right?
Yeah.
Okay, so the bug that I had was that I had this line here. Well, first off, I had a typo and I wasn't actually checking customer ID there, but this line for writing the row at the end, I had it inside of the conditional. And so like, and because, so I'll show you what the code was like this morning, right before we got on. All that was indented there. So this is what it was like this morning, very close to what it was here. See, ID, we changed the name of the parameter from ID to customer ID, and I hadn't done the update. So this will never pass because there is nothing called ID. It's just going to be a blank variable that we're comparing here to the first thing in the row. And so this case will always fail. And because this case, well, okay, that wasn't there this morning either, but whatever. Because this case always fails, we weren't going to write any lines. And then once we get to the end of the file, this file was just going to get overwritten with blank lines because we weren't ever going to write anything. And so I caught it. I was looking this morning, scratching my head as to why doesn't it work? Because conceptually what we were doing should have worked. And then I realized, aha, first of all, I need to make that the actual variable. And then I need to put the right, regardless of if we're updating a record or not, we want to make sure that we're writing everything to the new file that we're building that was in the old file, right? Let's go through this line by line. So first, we're going to define a list here of strings in a specific order that represent the names of the fields. So the reason why we're going to do this is because if we open up the CSV file using the CSV package here, see, we imported this package up here, CSV. Well, it has a method called dict reader. So up here, we just did normal reader. Well, a dict reader, which is what we're doing here, kind of, I guess it pulls in the CSV file as a dictionary, which we've worked with a little bit before. And that's useful because it has some names here. And in particular, it lets us index into the dictionary using the field names that we gave it, which is a lot more readable, right? Because what does row 1 mean to you as a programmer? Not so much, right? But
Yes.
the row, when you have an ID, well, obviously that's the ID in the row, right? And this is the name in the row and the password in the row. You get the idea. So yeah, that's pretty clever, right? So advantages of just finding stuff on the internet is we found an example and it actually is doing things better than the first example we did, right? Not that this one's wrong or anything. It's just what we should be thinking in our heads is, okay, this is using like hard-coded indexes, but when I come back and look at this in a year, am I going to know what the row at index 2 means? You know, like I'm going to have to scratch my head and I'm going to have to go look at the data file and be like 0, 1, 2. Oh, that's the password, right? But that's just not very obvious. So this is much, much better for like internal documentation. There's this concept. I don't want to harp and get off topic, but there's this concept called self-documenting code, which basically means you choose good variable names and you try to make your code obvious. And you certainly don't want the opposite of self-documenting code is like self-obfuscating code, where your code is just unnecessarily confusing and complicated for no good reason. And so you want to make it so that your variable names are really obvious, so that what you're doing is really obvious. I can't remember if I ever mentioned this, but once we get to Lambda functions, sometimes people will try to be really clever and do things in one line, where in my opinion, like a professional opinion, not just me as a person, it makes it way harder to maintain the code because someone else will come look at this fancy one-liner like a couple years in the future and be like, what the heck is this doing? Whereas if the person had just written like a for loop, everyone would know what the for loop does, right? A personal rant aside, that's why we're trying to pick good names here for, not good names, why we're trying to make our code easy to read in the future. So we pick the field names here, and then we open up a reader and a writer. And I'll get back to that in a second. And then you see it lets us index into all of the rows in the thing that we're doing. So I suppose I gloss over this without batting an eyelash because I've dealt with file. This is what we're doing here is called file IO, file input and output. You'll hear IO used as an abbreviation a lot. And you'll have to apologize, or I'll have to apologize up front and just say, if I ever just don't talk about something and you're confused, just tell me. Because the first time that we did this in intro programming way back when, I remember being like, well, what the heck is a file writer? Like what is that? What does it do? Because it's just this concept that, I mean, it's not that hard, but like, if you've never done it before, I'm just taking things for granted is what I'm saying. And so it's tricky trying to think like someone who hasn't done it before, because it's just been a while for me since I was there. But I was there at one point. At one point, I would have had no idea what I was doing here either. So what a reader does, this is a variable, right? And so we're setting a variable equal to the CSV package that we've pulled in, and then we're building something called a dict reader. And this thing, as you can see, must be a method because it takes in arguments, right?
Yes.
Follow everything I just said? Okay, so we're assigning a variable equal to the return value of a method from the CSV package that takes in a file. So we've got an open file here, and then a list of field names that we defined up here. Okay, so what this thing actually returns is a dictionary that contains a list of rows where the keys in the dictionary are the field names that we just defined. And you can see that because each row here is actually, I think it's an array of dictionaries. And because each row here has as indexes the strings that we put here for the field names, but there's a list of rows, right? Not just one row.
Yes.
So it's kind of a two-dimensional data structure representing the structure of our CSV file here. So that's what the reader does. Now, all the writer is it's doing the same sort of thing. It has the exact same data structure when we open this for writing, except what it does is it has a function down here that lets us write something back to this. So a reader, as you might think, it just takes in the data. It's a read version. You don't change the data when you have a reader object here. The writer lets you change or update the data, lets you write to it. Why do you use two? Like, hypothetically, could you do it all in one? Maybe. Because I bet you could open up the data in a writer and just go through it in a writer, but maybe not. I mean, I actually don't know the answer to that question. Sometimes the standards that are in place, I can't always explain it. But something you should get comfortable with is just accepting it. I know that's not very satisfying, but does it really matter to us here why we use a reader and a writer rather than just like one thing? Not really. Like that's just how it's done. I see, and I don't want to get off on another rabbit trail, but this happens a lot with like the new guys on our team, is that they'll come in and they'll ask why for everything. Why? And to a certain point, you just tell them, well, I don't know either. And I've been here for 2 years. So just accept it. Like, because if you want, and it's not a bad thing. It's not a bad thing to want to understand, like why things are being done the way they're being done. Because most of the time there's pretty good reasons for it. And there's logic and someone will be able to explain it to you. But sometimes it's also just because, well, that's how it was done. And we're not going to change it now because that takes too long. Or, like, this is just how the world works, like, accept it. Okay. So, yeah, you're getting my very opinionated take on all these things in the process of us going here. Okay. So to pull us back, specifically on topic, I'm sorry, I actually don't have super long because I have a meeting at 9 today. So what we're trying to do is update the customer record based on the information. So up here, we read in a record, and now we want to update the record, right? And so you see the parameters here. We have our customer ID and field. Actually, you see my C# invading there. Camel case. So actually, before I change gears, so I just explained what readers and writers were. The rest of this is just a basic for loop that goes through all of the rows. And right now I've set up what we will need to modify to do the modification of a specific row here. You see, I've set that up. After that, once we modify the specific row, that's what we'll want to do. We're going to go ahead and write, no matter if it's the row that we're modifying or if it's any other row, we're going to go ahead and write the row back to the file, or rather back to a temporary file that we then move into the main file. Make sense?
Yes, I've been wanting to ask about this with open example.csv, then R CSV. Open output file.csv. This is a file we create with this statement, right?
So
the output file.
Yes. So if we run this, this file here is going to get open for writing. It doesn't exist yet. This is why I'm calling it a temporary file. If you were on a system and we set, honestly, I'm kind of curious. Let's see what happens when we set a breakpoint here. I think if we set a breakpoint here, I wonder if we'll see it. Maybe not. No, regardless, it's a temporary file. So like it's, once we get to the end of the code that we've written here, we're going to be moving. This is a shell utility package, I think. And then we're moving the CSV file. We're going to overwrite the initial file we had with the stuff from the file that we had been creating. And this is the somewhat roundabout way, I guess, that you have to work with CSV files when you're updating things and overwriting data. So again, things I'm taking for granted, sorry. The open function, gosh, I really don't want to get into file descriptors right now. So basically, on a hard drive, when you have a file is a collection of information. Have you ever heard of a bit and a byte computer systems? So files are, you have a whole bunch of these bits. You have these electrical, wow, why is the word escaping me? They're built up of semiconductors, silicon doped. I can tell you what they're made of, but
are you thinking of electrons?
Transistors is what they're called.
Transistors, okay.
And so chips have millions and billions of these things, and each one has an electrical input that's like a 1 or a 0. So binary computer code is 1s and 0s, just millions and billions of them, right? That's how computers work, high level. And so when we read data in from the system, we want to be able to do things to that. So I'm going to be really hand wavy here just because I don't want us to go get off in the weeds here. If you're curious, you can ask me about it later. Like basically, how do programs execute in system memory on computers? And what does it mean to copy a file from the hard drive into system memory when the program's executing and stuff like that? But for now, when you call this open function, what you're doing is you're grabbing the file off of the computer, or here we're doing this on a server, but it's still computer. And you're getting that file with a certain kind of, I'm trying to be vague, but not like imprecise. You're getting that file with a certain purpose. So you put the R here, that means you want to read from this file. So you're going to grab this file from the system and you want to read from it. So you're going to do a specific set of actions on it. And over here, if this file, we want to grab this file and then we want to write to it. And implicit in this is that if this file doesn't exist, then we want to make it exist. That's normal when you open a file for writing. If it doesn't exist, you're going to make a new file and write to it.
Okay, I think I get it. Let me see if I can interpret it in my own language and just let me know if I'm right.
Sure.
So we create a function and set up something called field names, which essentially defines the order in which the information in the file is stored. Then we open the file itself to read from it and create something that we can write into. Then we set up a reader, which actually is going to read from that file, a writer, which is going to write to the output file and match them essentially in this way. Okay. Then we set up a for loop, which essentially tracks what we want to write, what we want to update, what we want to change. And when we have made the change, we're going to write that change into the output file and then move the output, what is in the output file, to the example file. Is that correct?
So everything sounded exactly right, except that we actually write the row whether or not we update it. This was the bug that I had mentioned this morning. It was why it wasn't working. If we only write the row when we update it, then when we overwrite our file, we're only going to have one row in it, right? Because right here, we're checking if the customer ID is row ID, we might do stuff. And then if we only write that row, we're only going to write the row of our customer, but we don't want to get rid of the rest of the data every time we update one file, right? So actually, inside of this for loop, the first thing we're going to do is if the customer is the customer that we're interested in, we're going to go ahead and update his stuff because that's the point of this function. And then we're going to write him. However, if it's not him, we're still going to write the row because we want to preserve all the rest of the data too. Does that make sense?
Yes. So what it sounds like is that any operation we do here, we have to be careful to make sure we write everything back, or else we might end up with an empty file afterward.
Right. Or if not empty, a file with only a subset of the data. Because I like the word that you used earlier was that the reader and the writer, we're opening these different files and we're going to match them. That's exactly what we're trying to do here. So if you view this as kind of like what's a good analogy here? I mean, I'm trying to come up with the like basically everything you do to one, you want to have end up in the other, right? So I was going to say mirror. Yeah. Mirror's not quite the right analogy. How about this? You know how in an hourglass sand falls down from the top chamber to the bottom chamber, but it's still the same sand, right?
Yeah.
That's kind of what we're doing. As we go through this loop, everything that was in the initial file, we want to go into the other chamber. We want it to trickle down to get passed into the other file. And then once the hourglass is done, so we've finished modifying all the data has passed from the top to the bottom, so that now output file, which is analogous to the bottom, has all the data. What are we going to do then? We're going to flip the hourglass again, right? So that what was the bottom becomes the top. I'm proud of myself. That's a good analogy. And so that is kind of what we're doing here, right? Everything is going to trickle down. Now, what we get to do as programmers is we get to control what happens when the sand passes from the top to the bottom, right? And so if we want to update something, we change the sand as it goes from top to bottom. If we want to delete something, we just pull out some specific part of the sand before it goes to the bottom, right? If we just exclude it, then by its very nature, right? By its very nature, it won't end up in the output. You see what I'm saying? So actually, writing delete will be really easy. Delete is going to be very similar to this, except easier.
Because there won't be a right row, really?
Well, will there though? Because we just said sand's going from the top to the bottom. And remember how I said we have to write all the rows, whether or not we change them?
Yeah.
So for delete, we want to write every single row that's not the row that we want to delete, right?
Yeah.
So if our file contains 100 rows, we want to write 99 of them, which means we will still need a writer. We will still need the output file as a temporary file. However, we're just going to skip one. That's what it means to delete in a specific way that this has been set up. For us to update, we're still going to actually write 100 rows out of 100. However, we're just going to make the write for one of those rows a little bit different than it was before. So everything is now set up here in this function, except that we aren't actually doing the update. So I've set everything up here, and this is the part that I wanted you to do. I'm sorry, this is getting a little bit more complicated than I intended for it to be. I
think that's good practice for me.
I was thinking that there might be like a CSV method that's like update row or something. So how I thought this function in my head, how this function was going to go down was that we would call CSV dot update row, and then taking the parameter of like field name and then new value. And so what you would have is that you'd have a function that like is called update record, and it has like one line in it that was going to be that. That was kind of what I was intending for this to be, but yeah, oh well. Learning experience, I guess. I'm kind of surprised it doesn't exist, honestly. Maybe if we found a different CSV package for Python, it might, but well, now you're learning about file IO too. So okay. So the remaining part of what we have left to write here is we want to update whatever field in the row the user chooses, which could be one of these four: ID, name, password, or cache. And we want to change it to the new value that the user passes in.
Okay.
So at this point in the code, I've left this as a to-do. I say do stuff, and then we pass just means we don't do anything in this case. So I want you now to come here and assign whichever value in the row corresponds to field to new value. So when I say assign, you should be thinking of a specific operator in your head.
Yeah. Okay. Yes, but the field is any of these four. So I can change anything. It's up to me to decide what to change. Change something specific.
So there's a clever way to do this, and then there's kind of the way that might seem most intuitive would be to have a conditional based on what field is, and then change any one of the four based on that.
Okay.
Do you understand what I just said?
I think so. I was just going to pick one of them and essentially change the value in it. That's like, for example, I was just going to write cache equals something else. But okay.
So it needs to work for any of the four, right? So we have
for any of the four, that's true. Yeah.
So what I was, I'll let you figure it out. I don't want to say anymore. I would say there's more than one way to do this. One of the ways is much shorter than the others. And so if you try to do it one of the longer ways, we'll come back and I'll show you the shortcut path.
Okay. Oh man.
Okay, so that's the right idea, but
it tells me local variable is assigned to but never used. So
does field represent the part of the row that we want to change though? So what is field in this function as we've defined it?
I expected it to be ID or name or password or cache, any of those.
Okay, so that's correct. But when you say it is one of those, like in terms of data types and in terms of where we are in our function, what does it mean for field to be cache, for example?
It has to be an integer. If it were cache, it would be an integer. And
but
something else, it would be a string.
So the value for the field would be an integer, right? But with the field itself, field here, okay, I'll just say it. So field's coming into our function. It's a parameter. It's coming in as a string, right? Representing one of these, ID, name, password, or cache. What I'm getting at is that a field comes into our function as a string right here, and you're assigning a string to something else, the string that we pass into our function. How is that going to change the row itself? Just think about it for a second. So let me phrase this a little bit differently. So down in the call to write row, how are we getting the values that we're writing to the row? It's not a trick question either. Down here. Are you still there? Hello? All right, so we kind of got cut off there due to network stuff. So I had just been talking about how field here was a parameter to our function, and it's coming in as a string. And so the question I posed was, does it make a lot of sense to assign the string variable that we have defined in our function equal to the other variable that we're passing in our function? And the question I posed was, how is that going to affect the row that we want to write here? And so I had just left off with down here in our call to the writer to write to our other file. So this is the bottom of the hourglass from that analogy that we talked about. How are we getting the value that we're writing into the row? So into the new row, I should say.
Okay.
So if ID represents the key name, and remember, this is a dictionary, the curly braces in Python, right? So this is how you define a dictionary. So we're saying that in this dictionary that we have, because we're using a dictionary writer that takes in these things as the key names. So for each one of the key names, you see that we're giving it a value, right? So if we want to reassign the value, how do we get the value of something in a row?
We get the value of something in a row. That would require calling up the key name. I'm not really sure how I'm supposed to do this.
So these things are key names, right?
Yes.
And we said that field itself is a key name, right? Containing one of these four values.
Okay.
So if we want to, conceptually, if we want to get the value of the thing in the row where the key name is field, how do we write that in terms of code?
Would that be this?
Mm-hmm. Now I want you to explain to me why. You don't sound so convinced.
Okay. Okay. Well, the row identifies where we are looking, and the field essentially is like a stand-in for any of the key names in question. That's what I was thinking, kind of following the pattern of row ID, row name, row password stuff. I'm not sure that makes a lot of sense.
No, I mean, you've got it, but the whole point that I was trying to get here is if we want to update something in the row, right? And so
Yes.
to update something in the row, the variable row has to be involved somehow, right?
Okay.
You know, how you access values in the rows, which is what we want to be changing. We don't want to change the field name. In fact, we can't change the field name in the framework we have it set up. We just want to get assigned to the value in the row where the key, that is the thing that we're changing, is equal to the thing that we passed in, the field that we want to modify. And then we want to assign that value equal to the new value that we're giving it. That's a lot of words for just this one line of code, but that's what it's doing.
Okay.
So let's see if it works. In our example right now, we have our row 7, Charlie Smith. It's his password, and he has $150. Okay. So we want, let's say he wants to update his name now. So name is one of the things. It's one of the possible key values here, right? And let's say he wants to update his name. So Charlie, who's ID 7, again, in our file here, ID 7, Charlie Smith. So we're calling this based on ID. He wants to update his name to Charlie Andrew Smith. Let's say he wants to include his middle name. So if this works properly, we'd expect that after we run this, that this will have Charlie Andrew Smith, not Charlie Smith. Do you understand why?
Yes, because it will replace Charlie Smith with Charlie Andrew Smith.
So once we get here, we could actually step through the debugger, or you could just take my word for it. Once this conditional gets hit and this conditional is true, customer ID, we're passing in a 7 here in this method call, right? So if 7 equals the ID in the row, right now we only have 2 rows. So the first time we run through this, the ID is going to be 3. So we're not going to jump into this conditional because it's false, right? So if 7 equals 3, we're going to skip it. So we're just going to write the row. We're just going to write the row for Bob Jones completely normally. And then Charlie Smith gets here. Well, his customer ID is 7. And if 7 is equal to 7, that's true. So we're going to jump in here, right? And then we're going to say, okay, we passed in field here is name. So we're going to set the name in the row where customer ID is 7, that's what we just did here, equal to new value. And what's new value? New value is Charlie Andrew Smith. That's what we passed. So we don't care what the value was before, but we're going to set it equal now, again, the field name, because that's what we passed here, for the row where customer ID is 7, that's what this conditional does, equal to Charlie Andrew Smith, which is what we passed. So if we run this, is it lagging? Can you hear me? Hello? Hello? All right, more network problems here, but we have to wrap up pretty soon because I have to go today. So unfortunately, it doesn't seem like our code here is working right off the bat. And so it also, unfortunately, it doesn't seem like the IDE is letting us properly debug here. And so what we're going to try to do instead, is use print statements, because hopefully the print statements will work, even if the debugger that's built in here seems to be having problems. Okay, so right now we're going to try printing out the field for the row when we run right there. Well, okay, so it doesn't think we ever actually hit that statement.
Yeah.
So we're passing in 7 there. Let's see if we print out row here. Okay, so we are getting the names. Aha, I figured it out.
Okay.
So you see this? What's special about this right here?
7.
Mm-hmm.
Oh, okay. It's I don't know. It looks like it's kind of dimmed. Like
Well, okay, not that. Well, I mean, that's because I highlighted it. What I was getting at,
okay.
I do have to go here, is that it's a string. And what I was just
Oh,
passing
right.
this function, is that a string? No, that's an integer, right? So
Okay. Okay. I
now
see.
let's see. Okay, we run our function now. We print out Charlie Andrew Smith. We go to our file, Charlie Andrew Smith.
Okay.
So our code actually does work. It was just that I was passing it in not as a string, but as an integer. Not tricky, huh? All right, well, that's where I'm going to have to cut off for today. So now we've done update as well. So if we run this again, we won't have anything in the console, but we'll see that Charlie Andrew Smith indeed has been updated.
Yeah.
So hopefully all that makes sense. You can take some time to go look it over again, make sure that you understand it all, and then delete tomorrow should go a lot faster because now we have the basic framework in place here. And so that's where we'll pick up again when we meet tomorrow.